So good morning dear students. In this video we will discuss about the bits related to amines which were asked in previous years NEET and JEE exams. So I am going to solve a few important bits related to this chapter. So try to understand and listen carefully. Now we'll see the first bit which were asked in last year AMPMT 2005. So first bit, electrolytic reduction of nitrobenzene in weakly acidic medium gives what? Okay, so here what is happening? Electrolytic reduction. So this is happening to the nitrobenzene. So in which condition? Weakly acidic medium. That condition also you have to remember, because once the condition changes, the product obtained also gets changes. So first write down to which one this reduction is taking place. Nitrobenzene. Write that nitrobenzene. So benzene which is attached by nitro group. Now it is undergoing which one? Electrolytic reduction. What is meant by reduction? Addition of hydrogen or removal of oxygen. So now this is taking place in presence of weakly acidic medium. Remember, it is weakly acidic. There are two conditions, strong acidic and weakly acidic. So in weakly acidic, this nitro group is completely converted into amine group on electrolytic reduction. So then we will get the final product here, NH2. So for this total reaction it requires 6 hydrogens. In that 6 hydrogens, 4 hydrogens will take up the 2 oxygens and converts into 2H2O. The remaining 2 hydrogens, whatever are left, that is added to the nitrogen, converts into NH2, and this is called aniline or aminobenzene, benzene amine. Okay, aniline is formed as the final product. This is under weakly acidic condition. If the same electrolytic reduction takes place in strong acidic medium. Okay, just imagine. So our answer we have got, that is aniline. If suppose the same nitrobenzene undergoes strong electrolytic reduction in strong acidic medium, the product may changes. See here, this nitro group converts into NHOH group. Nitro group is reduced into NHOH group. So then again it undergo rearrangement reaction. So what is meant by rearrangement? Within the same molecule, the position of a group changes from one position to another position. Then that is called rearrangement reaction. Then what happened? So OH from here is removed and it is attached to the para position. This is para. At para position you can see the presence of one hydrogen. So this hydrogen is removed. So this is added to NH and convert NH into NH2. So then OH group is added to this para position. Then we will get here NH is added by this para hydrogen, converts to NH2. OH from here is removed and rearranged to this para position, and we will get here. So this is called para aminophenol. Okay, this is phenol. At para position amine group is present. We will get para aminophenol as the final product. In which condition? In strong acidic condition. Okay, remember, if the same electrolytic reduction takes place to the nitrobenzene in strong acidic condition, we will get this product. If the same electrolytic reduction takes place at weakly acidic medium, you will get aniline. So now the condition is given is nothing but acidic medium. In acidic medium, you will get aniline as the final product. So the answer is the third one. That's why I am telling you to not only concentrate on the reactant and the product, even you have to concentrate in which reaction condition the reaction is carrying out, so that you want to remember in organic chemistry. Now we'll move on to the next bit. See here, they have given aniline. Aniline in a set of reaction yield a product D. So aniline undergo reaction with sodium nitrate and HCl. First it gives A. Upon reaction with CuCN, it can give B. B upon reaction or reduction in nickel and H2, it gives C. C, which is again reaction with nitrous acid, finally it converts into D. So that you want to find out what is D in the following set of reaction. The structure of the product D would be which one, that we want to find out. So write step by step the reaction. So here I am writing. So what is firstly, they have taken aniline. Write down aniline, C6H5NH2. When this aniline undergo reaction with sodium nitrate and HCl, It is many times we have seen while explaining also. While explaining especially diazonium salts, I have explained this reaction. In presence of sodium nitrate and HCl, this amine group is completely converted into diazonium salt. N triple bond NCl minus and plus diazonium salt is obtained. So this is what A obtained. Now this A again on reaction with cuprous cyanide. So B is obtained. In the reaction B is obtained. What is that B? So what happened? In presence of HCl, this reaction takes place. This hydrogen will take Cl, eliminates as HCl, and here the bond breaks and this group eliminates as N2. Whatever Cn is there, that Cn is going to attack this position or the carbon, then we will get Cn here. Cyanobenzene is obtained. Now the cyanobenzene upon reduction, what is reduction? So this is B. B upon reduction in presence of nickel. Okay, so this Cn we can also write in the form of C triple bond N. We can also write in this way. So if you break these two pi bonds, because pi bonds are less stable than the sigma bond, then what happened? Here reduction is taking place. 2 hydrogens are added here and 2 hydrogens are added to the nitrogen. Then you will get C6H5. C is added by 2 hydrogens, CH2. The triple bond converts to single bond and NH2, CH2, NH2. Benzylamine is obtained. Now this is what C. Okay. Now C again on reaction with nitrous acid. On reaction with nitrous acid, HNO2. Okay. It can be converted into benzyl alcohol. Benzyl alcohol. So this nitrogen and this nitrogen together eliminates as N2 gas. These two hydrogens take one oxygen, converts into, you can see first this nitrogen and this nitrogen is eliminated as N2 gas. Okay. Now 2 hydrogens present here take one oxygen, eliminates as H2O. Still one more oxygen is there. 2 oxygens were there. One is taken by hydrogen and eliminated as H2O. One more oxygen and hydrogen react together, converts to OH. That OH is added to the carbon, CH2OH. This is called benzyl chloride. CH2OH is formed as the final product. Now this is what D what we want. Okay. So in the product C6H5, we can also write this ring as C6H5. To the C6H5, CH2OH is attached. This is the answer. Fourth one. We got benzyl alcohol as the final product. Now we'll see the next bit. So now the third one, which one of the following is more basic than aniline? So this already we have discussed in the last video. So than aniline, benzylamine is the most acidic. So I have given the structures also in last video. You can see here. So triphenylamine, the first option what they have given is triphenylamine. Okay, this is triphenylamine, first option. Second one is para-nitroaniline. This is aniline. To this para position, if nitro group is there, this is called para-nitroaniline. And the third one, benzylamine. CH2NH2. This is called benzylamine. And the fourth one, diphenylamine. NH, another phenyl. This is diphenylamine. So if you see diphenylamine and triphenylamine, here nitrogen which is containing lone pair of electron, that is involved in delocalization with this benzene ring pi bonds. Okay, so such lone pair of electrons on nitrogen is not freely available. If such lone pair is not freely available, they cannot, their basic nature gets decreases. Okay, in the same manner, even in this case also, nitro group is electron withdrawing group. When it takes electrons from the benzene ring, then the lone pair of electrons on the nitrogen is given to benzene ring. Thereby the lone pair of electrons on nitrogen is again not in free state, thereby the basic nature or basic strength gets decreases. But in this case, benzylamine, The nitrogen is not directly attached to the benzene ring. It is attached to through this carbon. So that lone pair of electrons on nitrogen is freely available, which is not involved in delocalization. If it is freely available, it can abstract the proton very easily, so that its basic nature is always increases. So this is benzylamine is having more basic nature than the aniline. So the answer is the third one. Okay. Now the next bit. Which one of the following on reduction with lithium aluminum hydride yields secondary amine? So for this we want to write reactions. We will write the reaction. Okay. So what we want to prepare? We want to prepare a secondary amine on reduction with lithium aluminum hydride. Which among the following? They have given 4 options. Which among the following will leads to give secondary amine as the product on reduction? So first write down the first option. What is first option? What they have given? Methyl isocyanide. So methyl isocyanide formula CH3N triple bond C. Now it is undergoing reduction in presence of lithium aluminum hydride. So in presence of lithium aluminum hydride, the pi bonds involves in breakage. Then the nitrogen is added by 2 hydrogens, carbon is also added by 2 hydrogens. Then we will get CH3 NH single bond CH3. That's it. Okay, we got this as the final product. Understand? So now this is which type of amine? It is secondary amine. It is secondary amine because on nitrogen 2 alkyl groups are present, then we can say it is a secondary amine. The first compound can give, methyl isocyanide can give secondary amine. In the same manner we can also test with the second one. What is second option given? Acetamide, right? Acetamide. Acetamide formula R C double bond O NH2. In place of R I have taken CH3 C double bond O NH2, which is acetamide. Now again it is undergoing reduction in presence of lithium aluminum hydride. Okay, when it undergo reduction in presence of lithium aluminum hydride, totally 4 hydrogens are required. In the 2 hydrogens take this oxygen eliminated as H2O. Still 2 more hydrogens are there, right? Those 2 hydrogens are added to this carbon, converts to CH3, CH2, NH2. Now you can see on nitrogen directly only one carbon is attached. Then we can say it is a primary amine. Okay. The second compound acetamide can give primary amine. In the same manner you can also test with the third one. So what is third one? Methyl cyanide. So third option is methyl cyanide. CH3 C triple bond N. It's not isocyanide, it is cyanide. When it undergo reduction in presence of lithium aluminum hydride, this double bond involves in breakage. 2 hydrogens are added to this carbon, 2 hydrogens are added to nitrogen. Then we will get CH3 CH2 single bond NH2. Now here you can see to the nitrogen only one carbon is directly attached, so we can say it is a primary amine. Third one is giving primary amine. In the same manner nitroethane also gives the primary amine. So which among the following options can give secondary amine? The first one. What is first one? Methane isocyanide or methyl isocyanide. This is the answer which can give secondary amine on on reduction in presence of lithium aluminum hydride. Now we'll move on to the next bit. The next one is in a reaction of aniline, a colored product C is formed. In a reaction of aniline, aniline is nothing but benzenamine. So in reaction of benzenamine or aniline, a colored product C is obtained. We want to find out what is that C. Okay, here C you can aniline is given as A. When it is on reaction with NaNO2 and HCl, B is obtained. B, which is on reaction with this aromatic secondary tertiary amine, it can give C. What is that C? We want to find out. Are you clear? Now we will see step by step. Aniline we can also write in this manner. Now this aniline undergo, this is what A. Now this aniline undergo reaction with sodium nitrate and HCl. As you know, when aromatic primary amine undergo reaction with sodium nitrate and HCl, we will get the product as diazonium salt. Okay, here it results diazonium salt. N2 or N triple bond NCl minus plus. This is diazonium salt, which is nothing but B. Now this B undergo reaction with this one. At this para position, one hydrogen will be present, right? So that hydrogen takes up the Cl, eliminates as HCl. Okay, this hydrogen takes up the Cl, eliminates as HCl. Now write the product. N triple bond N Okay, there is no hydrogen Cl. Now the bond is made between nitrogen and this carbon. On this para, at this para position, nitrogen CH3 is present. This is our product C. Okay, you can check this product here. Okay, so you can check your answer with this. This is our C. So C is obtained in the first option itself. C6H5 N double bond N, C6H4 N, CH3 taken twice. So the answer for this question is the 1. So this is the C, structure of C. See the next bit. Predict the product in the given reaction. So what they have given in the reaction? So C6H5 NHCH3. Here NHCH3. This is secondary amine. When it undergo reaction with sodium nitrate and HCl. Okay, it's not primary amine. You have to remember it is a secondary amine. Primary amine leads to give diazonium salt, whereas it is aromatic secondary amine. So always aromatic secondary amine leads to give this kind of product. Okay. So here NCH3NO2 is formed. So this is the product which is obtained when aromatic secondary amines undergo reaction with this NO2, NaNO2 and HCl. So the answer is the first one. So next question. See next question. Nitrobenzene can be prepared from benzene by using a mixture of concentrated HNO3 and concentrated H2SO4 in the mixture. In this mixture, nitric acid acts as which one? Okay, so H2SO4 and HNO3 is a mixture of nitration mixture we can call it. Whenever benzene undergo reaction with nitration mixture, it can give nitrobenzene. So in this mixture, HNO3 can act as which one? It can always act as a base. Remember, in this case always it can act as a base. Are you clear? Now we'll see the next bit. And next bit is, which of the following statements about primary amines is false? False statement we have to find out, not the correct statement. So according to primary amines. Now alkyl amines are always stronger base than the aryl amines. Exactly, alkyl amines are more basic than the aryl amines, because in aryl amines the lone pair of electrons and nitrogen involves in delocalized. This is the correct statement. Which one we want to pick? We have to pick the false statement. Then move on to the next one. Alkyl amines react with nitrous acid to produce alcohols. Even this is correct. Okay. So alkyl amines on reaction with nitrous acid, they can produce the alcohols. Next one. Aryl amines react with nitrous acid to produce phenols. It's wrong statement. Aryl amines on reaction with nitrous acid, they do not produce phenols. Okay, nitrous acid they can produce diazonium salts. So this is the false statement. Okay, aryl amines do not produce phenols on reaction with nitrous acid. Next one. Alkyl amines are stronger bases than the ammonia. Exactly. So ammonia is weaker base than the alkyl amines. Even this is also correct. The correct statement. So the false statement is the third one. And the next question. What is the product obtained in the following reaction? Okay, here they have given a reaction. In that reaction you want to find out the product. So in this case what is happening? Nitrobenzene undergoing reduction with zinc and ammonium chloride, and you have to find out the product. So first write down the reaction. Nitrobenzene. When nitrobenzene undergo reaction with zinc and NH4Cl, if reduction takes place with zinc and HCl, that leads to give primary amine. But here we are discussing about a reduction in presence of zinc and NH4Cl. It leads to give hydroxylamine NHOH. We will get partial reduction will takes place. Okay, one hydrogen is added to nitrogen, another hydrogen is added to hydrogen with oxygen, you will get NHOH. So this is our product, second one. If the reduction takes place in presence of zinc and HCl, the product is said to be amine, aniline. Okay, we will get this. But here the condition is changed. Zinc is reducing this NO2 in presence of NH4Cl. So the product is this one. Okay, now we'll move on to the next bit. Which of the following compound is most basic? Okay, which is most basic? As we know, the most basic one is nothing but benzylamine. So this is what benzylamine, many times we have discussed. Okay, so in this case nitrogen is directly attached to the benzene ring, in which the lone pair of electrons involved in delocalization. Even here electrons of nitrogen is involved in delocalization. Even here electrons of nitrogen is involved in delocalization because directly attached with the benzene ring. But in this case it's not directly attached to benzene ring, it is connected through the carbon atom. So benzylamine is more basic than the other three. Answer is the second one. Next one, an organic compound C3H9N when treated with nitrous acid give an alcohol and nitrogen gas is evolved. This is what A. So this A on warming with CHCl3 and caustic potash give C, which on reduction gave isopropyl methylamine. Product what is A? So we want to find out what is A. So first write down the reaction. So C3H9N. C3H9N we can write in different forms. I am writing here C3H9 in the secondary amine form. Sorry, primary amine form. Okay. So when the C3H9N, first it reacts with which one? Nitrous acid. Nitrous acid formula HNO2. By reacting with this HNO2, what it is forming? An alcohol and evolving nitrogen gas. So this nitrogen and this nitrogen can be released in the form of N2 gas. Then CH3, CH, CH3. These two hydrogens will take one oxygen, eliminates as H2O. It evolved nitrogen gas also. Now what left? Oxygen here and hydrogen here is left, that is added to this carbon atom, and we will get here alcohol. Exactly what they have given in the sentence that we have got. When this A, this is what A undergo reaction with nitrous acid, it releases nitrogen gas and can form alcohol. Alcohol is obtained. Okay, now on warming with CHCl3, on warming with CHCl3, it can give C. A is on warming with CHCl3, it can be converted into this CHCl3 and caustic potash, that is KOH. It can give C, okay, which on reduction gives isopropylamine. So that C is nothing, but here the reduction will take place and converts into CH3, CHN, C, CH3. On reaction with chloroform, always this amine leads to give isocyanides. Isocyanide is formed. This isocyanide which is on reaction with reduction or reducing agent, it can undergo reduction. Whenever you do reduction to this, what happens? NHCH3 is obtained. Hydrogen here and 3 hydrogens here are added, converts to NHCH3. CH3, CH, CH3, NH, CH3. Okay, this is the final product. What is final product? They have told us. So isopropyl methylamine. So this is isopropyl and this is methylamine. Isopropyl methylamine is obtained as the final product, that is C. Understand? Now what is A? So A is nothing but CH3, CH, CH3, NH2. This is what are A. So A is nothing but this compound. Understand? Now we'll move on to the next bit. Nitrobenzene on reaction with concentrated HNO3 and H2SO4 at 80 to 100 degrees Celsius forms which one of the following compound? Nitrobenzene. Okay, nitrobenzene. Right, nitrobenzene. So when it reacts with nitrous acid and sulfuric acid at 80 to 100 degrees Celsius temperature, which one of the following product is obtained? So the product obtained here is nothing but another nitro group is attached at meta position. This is called nitration. So when nitration takes place to the nitrobenzene, we will get meta-nitrobenzene. This meta-nitrobenzene is also known as, this is first position, second position, third position, 1,3 dinitrobenzene, because they have mentioned here IUPAC names as options. So we have to write IUPAC name for the product. So for this product, IUPAC name is 1,3 dinitrobenzene. So the answer is the third option. So like that we want to convert the matter into the reaction, then it becomes very easy to predict what is the product. When nitrobenzene undergo reaction with nitrous acid and sulfuric acid, this is a nitration mixture. In presence of nitration mixture, nitration will take place to this and it can be converted into 1,3 dinitrobenzene. Now we'll move on to the next bit. See here 13th bit. In the reaction of this compound, it is a substituted diazonium salt. Upon reaction with A, it can be converted into this metabromonitrobenzene. Metabromonitrobenzene. What is A? What is A we can use for this conversion? So for this conversion, after conversion, you don't see the presence of N2Cl group. So for this, we can use H3PO4 and water as a reagent. H3 in presence of H3PO2 and water. In presence of H3PO2 and water, this substituted diazonium salt converts into metabromonitrobenzene. So the answer is the H3PO2 and H2O. Okay. Now the next one. So in the following reaction, the product A is, so these two undergo reaction. This is diazonium salt and this is aniline. In presence of acidic medium, when these two undergo reaction, what is the yellow dye? This we have seen in previous reaction. Anyhow, I'll write once again. Listen. So take this diazonium salt. N triple bond N Cl minus plus. Now it react with what? Aniline. Aniline also we can write in this manner. It's not a problem. Okay, we can also write this. This is aniline diazonium salt. When these two undergo reaction, hydrogen of the aniline present at para position react with this Cl and releases as HCl. Now this nitrogen directly added to the para position carbon of aniline. N double bond N. Here NO2 we will get, sorry, NH2 we will get, this is our product A. This is in yellow color and this is called yellow dye. So now the answer is this one. So which one is having this one resemblance? Fourth option. So C6H5 N double bond N C6H4 NH2. So this is the yellow dye which is obtained after this reaction. That is about the answer for the 14th one. Now the next one. Which one of the following will be the most stable diazonium salt? I already told you even in the last video, aromatic diazonium salts are the most stable diazonium salt. This is aromatic diazonium salt. Even it is aromatic, whereas diazonium salt is not directly attached to the benzene. Okay, diazonium is not directly attached to the benzene ring, but here diazonium is directly attached to the benzene ring. So this is the answer. Now the next one, the electrolytic reduction of the nitrobenzene in strongly acidic medium. So in the first case itself I have told you. So whenever reduction takes place in presence of strong acidic medium, for nitrobenzene. This is nitrobenzene. When electrolytic reduction takes place in strong acidic medium, now what happens? It will not form aniline. It can form para-aminophenol. Okay, here NH2, and first what happened? It converts into NH and OH. First it reduced to NHOH, which is on again rearrangement. This OH group rearranges to this para position. Hydrogen present at para position is added to nitrogen. Then we will get here NH2 and here OH. This is para-aminophenol. Okay, this is phenol. To this para position amine group is attached, then that is called para-aminophenol. Answer is the fourth option. Next one. In the following reaction, NH2, this is benzoyl chloride, in presence of NaOH, we got this product. This is called benzoylation. So addition of this benzoyl chloride to the aniline is called benzoylation. If you take acyl group, then it is called acetylation. But here we are taking benzoyl chloride, then this is called benzoylation. So this benzoylation is an example of Scott-Bauman reaction. Benzoylation. In synopsis I have given this reaction. If you want, you can check. Okay. Benzoylation of aniline is an example of Scott-Bauman reaction. Next one. Method by which aniline cannot be prepared is. Okay, in which method we cannot prepare aniline. Aniline is an aromatic amine. Such aromatic amine cannot be prepared by this phthalimide reaction because chlorobenzene is not that much easily undergoing reaction with phthalimide. So this phthalimide reaction is not meant for the preparation of aniline, which is nothing but aromatic amine. Now the next bit. The number of structural isomers which are possible with the molecular formula C3H9N. So with this molecular formula, what are the number of isomers possible that we have to find out. So first write one by one. I am taking here C3H9N. First we will write CH3, CH2, CH2, NH2. This is first possible isomer. 1, 2, 3. 3 carbons are there. Hydrogens 3 plus 2, 5, 5 plus 2, 7, 7 plus 2, 9. 9 hydrogens and 1 nitrogen. This is first possible. Next second one. CH3, CH, CH3, NH2. Again it is 1, 2, 3. C3, H9. 3 plus 3, 6. 6 plus 2, 7. 7 plus 1, 9. And 1 nitrogen. This is second possibility. Third possibility, CH3, CH2, NH, CH3. Even you can check here also the molecular formula is same. Next, fourth possibility is CH3N, CH3, CH3. This is fourth possibility. Here you can also see 1, 2, 3 carbons, C3H9N. Okay, so total number of possibilities are 4. Only 4 isomeric structures are possible with the molecular formula C3H9N. So the answer is the third one. Okay, now we'll move on to the next bit. The correct statement regarding to the basicity of aryl amines. Basicity of aryl amines. So correct order of basicity. Correct statement we have to pick. See the first one. Aryl amines are generally less basic than the alkyl amines. Exactly. Because alkyl amines are more stable, more basic than the aryl amines. This is correct statement. First one is the answer. So still many bits are there in this neat part. You try to solve that bits. Now I am going to solve few more bits present in JEE. Okay. So in this the first one is primary amine will react with chloroform and KOH. The product we have to find out. Primary amine general formula are CH2, NH2. Generally I am taking. When it react with chloroform followed by KOH, what will be the product we want to find out? Okay, we will get here cyanides or isocyanates as the product. Okay, clear? So this 2 hydrogens are removed. In the place of hydrogen, carbon is added. Then we will get RCH2NC. RCH2N, this carbon is added. We will get isocyanide. Isocyanide as the product plus this 3 react with 3 potassiums and converts into 3KCl plus it releases H2. So these are the byproducts and this is the main product. Main product here is obtained is nothing but isocyanide. Isocyanide is the final product and this reaction is called carbylamine reaction. We can also call this isocyanide as carbylamine, which is having offensive odor, that is very bad smell it leads to give. Okay, now the next one, the compound formed in the positive test for the nitrogen with Resins solution of an organic compound. Okay, Resins test is used to detect nitrogen. Resins test, it is used to detect nitrogen which is present in the organic compound. In that the final product is nothing but ferric ferrocyanide. So ferric ferrocyanide, because of the formation of ferric ferrocyanide, the total solution converts into Persian blue color or green color. So by this Persian blue color or green color, we can confirm that the given organic compound is containing nitrogen. That Persian blue color is obtained due to the formation of ferric ferrochloride. So that the answer is the first one. So in Resins test, this is formed as the final product. Now the next one, which one of the following methods is neither meant for the synthesis nor for the separation of amines? So all the first 3 can be used for preparation and separation of the amines, whereas Woods reaction cannot be used. So this Woods reaction is used to synthesize alkanes, especially higher alkanes can be synthesized by this Woods reaction. So it is not meant for the preparation or separation of the amines. Next one. Reaction of cyclohexanone with dimethylamine in presence of catalytic cyclohexanone with dimethylamine in presence of catalytic amount of an acid forms a compound if water during the reaction is continuously removed. So here the reaction is taking place between cyclohexanone and dimethylamine. Between these two, the reaction is taking place in presence of catalytic amounts of acid, forms a compound. So during this reaction continuously we are removing water. So first we will see the reaction. So cyclohexane, if it has ketone, then it is called cyclohexanone. Now it reacts with what? Dimethylamine. You just write dimethylamine. Here I am writing general representation of dimethylamine. This is dialkyl amine. Okay. Now in this reaction, the reaction is taking place in an acidic medium. During this reaction continuously water is removed. So to remove water we need 2 hydrogens. So I am taking here hydrogen present on the adjacent carbon atom of this ketone because it is highly acidic in nature, which can be released in the form of H+. It is adjacent to the carbonyl group. That carbon is called alpha carbon and the hydrogen is called alpha hydrogen. Remember, alpha hydrogen is always highly acidic. So that hydrogen from here, oxygen from here, this hydrogen together eliminates as H2O. Then what happened? Here a bond is broken. So 1 pi bond and this carbon will make a bond with nitrogen. Then we will get a double bond, single bond, N, R. This is amine. Amine is attached to the double bonded carbon. Then it is called ene. Double bonded carbon, nitrogen is attached. Ene, amine. We can call it as an in amine is formed as the final product. So the answer is the first one. Okay, enamine is formed as a final product whenever cyclohexanone undergo reaction with dialkyl amine or dimethylamine. Okay, it is a secondary amine. Secondary amine and reaction with cyclohexanone in presence of acid, it leads to give enamine. Next one, in the chemical reaction. This is chemical reaction. So during this reaction, what is the final product? This is what we have seen here. In place of or, they have taken CH3, CH2, NH2 when react with chloroform and 3KOH. A product is CH3, CH2, NC and the B product is 3KCl. CH2, CH3, CH2 they have written, we can also write it in the form of C2H5NC, C2H5NC and 3KCl. So the answer is the fourth one. the same reaction. Okay, but here they have asked you to find out what is A and B. Here A is isocyanate, B is the potassium chloride. These two are the answers. Now we'll move on to the next bit. See the next question. Toluene is nitrated and the resulting product is reduced with tin and hydrochloric acid. The product so obtained is diazotized and then heated with the cuprous bromide. The reaction mixture so formed contains. Okay, first take toluene. Toluene is a compound which is containing CH3 on benzene ring. Okay, it is nitrated and then resulting product. Nitrated in the sense it can undergo nitration reaction. On nitration we will get two products. One is orthonitrotoluene, other one is para-nitrotoluene. Because methyl group on benzene ring can act as ortho-para directing group. The coming electrophile nitro can attack either at ortho position or at para position. If it attacks at ortho position, then we will get orthonitrotoluene. If it attacks at para position, you will get para-nitrotoluene. Okay. Now the product is reduced with tin and HCl. Now it is reduced with tin and HCl. On reduction, what happens? NO2 group is converts into NH2. Then we will get orthoaminotoluene. Orthoaminotoluene. So then it is diazotized. Then followed by first diazotized. To undergo diazotization, it reacts with NaNO2 and HCl. So in presence of this, NH2 group is converted into N2Cl. CH3 and here N triple bond N, Cl minus and N plus. Now this again on reaction with which one diazotized is happened, then again heated with cuprous bromide, CuBr, in presence of HBr. Okay. So what happened? This hydrogen will take this Cl, eliminates as HCl. This N2 is released as N2 gas. Bromine is added to this position. We will get C6H4, CH3 and here bromine. This is orthobromotoluene. Okay, it leads to give orthobromotoluene as the product. Next one, C. When this para-nitrotoluene undergo reduction, tin and HCl, what you will get? CH3 here and NH2 here. Para-aminotoluene is obtained, which again on diazotization, NaNO2 and HCl. First it converts into diazonium salt. CH3 here as it is, in this place N2Cl is obtained. When again it reacts with cuprous bromide and HBr. These two are released. In this place Br is substituted. Then we will get CH3 and Br here. This is called para-bromotoluene. Para-bromotoluene. This is orthobromotoluene. Orthobromotoluene and para-bromotoluene are formed as the final product. It leads to give a mixture of ortho and para-bromotoluenes. Okay. Now next one. In the chemical reaction, when aniline undergo reaction with this, first product is nothing but diazonium salt. Aniline undergo reaction with NaNO2. This is very familiar reaction. Many times we have seen this reaction in solving the bits. On this reaction, NH2 converts into N2Cl. When again it reacts with, this is what A, tetrafluoroboric acid. Okay, so by reacting with tetrafluoroboric acid, this diazo group is replaced by fluorine. Then we will get fluorobenzene. Fluorobenzene. So the answer is fluorobenzene. Benzene diazonium chloride. A is benzene diazonium chloride. B is fluorobenzene. Answer is the B. Okay, like this try to solve remaining bits present in this JEE corner also. You will get more knowledge. Okay, by following synopsis you want to try to solve as many as possible bits, then only you can capable to answer the bits in objective exam. Okay, this is about the chapter amines. In next video we will be with the another new chapter. So I hope you understood this chapter. So keep the synopsis whatever I have given or I have explained in the previous video beside you while solving this problems or the bits present in this chapter.